ABCD is a rectangle in which AD is 2 times the length of AB. So where's AD? So that is length x, and that would be length 2x, because it's twice as long. Then AE bisects BAD. B to A to D, so that means angle 1 equals angle 2. So angle 1 equals angle 2, and the reason for that is this here. Okay, we just get that there, and happy days. Now, prove that E is the midpoint of BC. So prove somehow that E cuts this in half. Alrighty. Now, what can we say here? Angle 2 equals angle 1, no bother. It's a rectangle, so these are parallel lines. So that would mean that angle 4 is the same as angle 2 because it's alternate. Okay. And then what that means is that it follows that angle 4 equals angle 1, and this would mean that it's an isosceles triangle. Therefore, triangle ABE is isosceles. And if it's isosceles, it means that AB and BE are the same, so it follows that AB must be equal to BE. Right? And what we've proved earlier is that, and we're given, if we divide both sides by 2, we're given that AB is a half of AD. So this proves that BE is a half of AD, and we know because it's a rectangle, AD is the same length as BC, so therefore it follows that BE is half the length of BC. AD equals BC, or the length of AD equals the length of BC because opposite sides of a rectangle. So that's proven that's the midpoint. Hence, E is the midpoint of BC. Alright, that one wasn't too bad. I'm starting to warm up now. 14. PQRS is a parallelogram. K is the perpendicular bisector of PQ. So what straight away that means is that it means that this is the same length as this one, and M is the perpendicular bisector of QR, so it means that one equals Q to here equals here to R. Proof that PS, which one's PS? Proof that PS, so I'm trying to prove that this one here is the same as RS. Well, that seems like a pile of joy. Now, actually lads, you're not able to do 14 because it involves congruent triangles, which we haven't covered yet. So we actually do not have to do this question. So 14 is a no-go, so we're going to skip it. We don't have to do question 14. It's not on. So 16. ABCD is a parallelogram. The line BG bisects ABC. So that's angle 1 equals angle 2. Angle 1 equals angle 2. And that will be given because of sorry, get rid of that. Let's say BG bisects angle ABC. H is an element on the line CD, so H is on the line, is if you continue C to D, it's part of that line, and it's also off the line B to G when you continue BG onwards. Prove that AB, which is this length here, we want to prove that that's the same length as AG. So we want to prove essentially that the triangle A to B to G is isosceles. That's essentially what this question is asking me to do. Prove that this is isosceles. Okay, so here's what we're going to do. We call U angle 3. Okay, so we got angle 1 equals angle 2. We already had the reason why for that. This here, BG bisects ABC. Now, next thing we're going to do is I'm going to say therefore we have alternate angles as well. We have angle 2 equals angle 3, alternate angles, because 2 equals 3, alternate angles. Okay, so angle 2 equals angle 3. It follows that if angle 1, I want to prove angle 1 equals angle 3, and that would prove that the two of them are isosceles. So I'm about to do that now. Therefore angle 1 equals angle 3. Therefore, or hence, triangle ABG is isosceles, and hence AB equals AG. Hence AB equals AG. And we're done. Happy days. Next thing it wants me to prove is that DG equals DH. So DG equals DH. So once again, I'm probably going to have to prove that things are isosceles to make this work. I'm going to shrink that down because it's taking up too much space. Now, here's what we're going for this time. Okay, I'm going to call this angle 4. Excuse me. Oh, we have this already, it's easy. Angle 4, angle 5, alright? So I'm going to call this to prove angle 4 equals angle 5. Okay, so what we're going to say is that angle 3 equals angle 4 because they're vertically opposite. Now, if you don't know what vertically opposite means, it means they're different sides of an X, vertically opposite. Okay. Now, there's also an alternate in here as well. We see angle 1. Oh, sorry. Do this in a less messy manner. See this? There's a Z shape for you. It's part of a parallelogram, which means they're alternate angles. Okay, so because AB is parallel to CH, we can say that angle 1 equals angle 5 because they're alternate. Okay, and then following that, what we can then say next is that angle 4 therefore equals angle 5. It follows that angle 5 is the same as angle 4, and we know that angle 3 equals angle 1. So we're looking to prove that 5 equals 4. It follows that angle 3 equals angle 5. And now we know that angle 3 equals angle 4 equals angle 5. This means the triangle GDH is isosceles. Therefore, DG equals DH. Fantastic. Now, last one. AD equals CH. So A to D equals C to H. Now, how are we even going to go about doing that? A to D equals C to H. So let's find out. Okay. So AD is equal to AG plus GD. C to H is the same thing as C to D plus C to D plus D to H. Okay, now what we can say about AD is that we can also say that AB equals CD because they're opposite sides of a parallelogram. Yeah, you get the gist. Opposite sides of a parallelogram. Okay, and then we can say therefore AG, because AG is equal to AB, AG equals CD. So this means that AD is equal to CD plus GD, and as we proved earlier, we proved that GD equals DH, so therefore AD is equal to CD plus DH, and therefore both of them are the same length, so hence CH equals AD. And that's it done. I might not get around to 17 right now, but I'll get there later on. So what did we just do? I think we already did 13 and 16 there, and we weren't able to do 14.